Today, I want to talk about atoms and molecules. Education is not the learning of facts, but the training of mind to think. Training of the mind to think. So said Albert Einstein. Education is not the learning of facts, but the training of the mind to think. When I say this, I remember my daughter Priya. That's why I have put the photo of my daughter here. Let us begin the subject atoms and molecules. Efforts never fail. We are going to talk on the subject atoms and molecules. I am going to deliver this lecture as per the NCERT textbook only. I am not going away from the textbook. So, textbook, I am taking this topic atoms and molecules and explaining one by one. First, Lavoisier and Provost established two important laws of chemical combination. One is law of conservation of mass. Law of conservation of mass states that mass can neither be created nor destroyed in a chemical reaction. Again, we have to read this law of conservation of mass. It is very important. Line by line, word by word, you have to see. Law of conservation of mass states that mass can neither be created nor destroyed in a chemical reaction. That is very important. So we go to the next one. To prove this law, see the figure 3.1 of NCERT textbook. You have to keep your textbook side by side here and you have to see the figure there. Experiment. I have taken barium chloride and sodium sulfate. In the book, they have not mentioned this. So now we will prepare this. Prepare barium chloride solution in water in ignition tube. There is an ignition tube, a small tube will be there in the figure, that is called the ignition tube. So in that ignition tube, barium chloride is a solid, then you have to put it with water. That is why it is mentioned here, barium chloride aqua, BaCl2aq. Take conical flask and pour sodium sulfate in water. Similarly, sodium sulfate aqua. Aqua means in solution. Put the ignition tube inside the conical flask as shown. Close the beaker now tightly with a cork. Close the beaker completely. It should be completely tight, airtight. Now we have to measure the weight. Measure the weight. Say it is p grams. Now tilt the flask and swirl it. Swirl it. Swirl refers to a circular motion, that is twisting. Both solutions are mixed thoroughly now and a chemical reaction takes place. Mixing barium chloride in water with sodium sulfate in water gives a white precipitate of barium sulfate and sodium chloride. Sodium chloride is getting dissolved in water. So we now see the reaction. The reaction has taken place. We see this reaction by forming a chemical equation. BaCl2 barium chloride aqua plus Na2SO4 sodium sulfate is equal to barium sulfate BaSO4 solution that is getting precipitated downwards plus 2NaCl aqua, that is sodium chloride. Now sodium chloride is getting dissolved in water itself, completely dissolved just like a common salt. Now measure the weight. You will find that the mass will not be changed after the chemical reaction. It will be the same p grams. The experiment explains the law of conservation of mass. Here the symbols are very clearly given. Ba B is capital and A is small letter you have to put. Ba is the symbol for barium. Cl is the symbol for chlorine. Cl, C capital, L small letter you have to put. So now this explains the law of conservation of mass. The other symbols are Na, you know, N capital, A small letter is the symbol for sodium. S is the symbol for sulfur. O is the symbol for oxygen. AQ is the abbreviation for aqua water. Once again, we will read the law of conservation of mass. It is important. We have to read many times so that we don't make any spelling mistake. We don't also forget to put proper words. Law of conservation of mass states that mass can neither be created nor destroyed in a chemical reaction. The word chemical reaction is very important. Again, I read law of conservation of mass. Law of conservation of mass states that mass can neither be created nor destroyed in a chemical reaction. Next law is law of constant proportions or law of definite proportions. What is the law? Law of constant proportions or law of definite proportions. This law was stated by Provost. This law was stated by Provost, the scientist. This law states in a chemical substance, the elements are always present in definite proportions by mass. In a chemical substance, the elements are always present in definite proportions by mass. We will see this. If you see ratio of mass of hydrogen to the mass of oxygen is always 1:8. Whatever be the source of water, it is always in the ratio 1:8. If 9 grams of water is decomposed, 1 gram of hydrogen and 8 grams of oxygen are always obtained. In ammonia, for example, nitrogen and hydrogen are always present in the ratio 14:3 by mass. Dalton's atomic theory provided an explanation for the law of conservation of mass and the law of definite proportions or constant proportions. The Dalton's atomic theory is the one which is giving a clear explanation for the law of conservation of mass and law of definite proportions. We will see that now. Now, Dalton's atomic theory. All matter is made up of very tiny particles, called atoms, which participate in chemical reactions. These very tiny particles participate in chemical reactions. Atoms are indivisible particles. They cannot be further divided, which cannot be created or destroyed in a chemical reaction. Atoms cannot be further divided, they cannot be destroyed, or they cannot be created in a chemical reaction. Atoms of a given element are identical in mass and chemical properties. Identical in mass and chemical properties. Atoms of different elements have different masses and chemical properties. Different elements have different masses and different chemical properties. Atoms combine in the ratio of small whole numbers to form compounds. The relative number and kinds of atoms, are constant in a given compound. The number of atoms are constant in a given compound. For example, if I say H2O means there will be only 2 hydrogen and 1 oxygen. We will take an example now to show the law of conservation of mass. In a reaction, 5.3 grams of sodium carbonate reacted with 6 grams of acetic acid. The products were 2.2 grams of carbon dioxide, 0.9 gram of water, and 8.2 grams of sodium acetate. Show that these observations are in agreement with the law of conservation of mass. Simple problem. To show you only they have shown this problem. They have not used any formula here for making you to become complicated. Sodium carbonate plus acetic acid plus equal to sodium acetate plus carbon dioxide plus water. Now this is the reactants, this is the product of the reactant, mass of the product. Now mass of the reactants, sodium carbonate plus acetic acid is equal to 5.3 grams plus 6 grams is equal to 11.3 grams. Mass of the product. After the chemical reaction, the products are carbon dioxide, water and sodium acetate. Sodium acetate. 2.2 grams, 0.9 grams, 8.2 grams, that is equal to 11.3 grams. Both reactants, mass of the reactants and mass of the products are same. So they are equal. Mass of reactants is equal to mass of product. So it is as per law of conservation of mass. It is as per the law of conservation of mass. Now another example. Hydrogen and oxygen combine in the ratio of 1:8 by mass to form water. What mass of oxygen gas would be required to react completely with 3 grams of hydrogen gas? This is the question. How much grams of oxygen is required? Now we have given a mass ratio, that is 1:8. That is 1 gram of hydrogen will react with 8 grams of oxygen. That is the answer we get from the ratio. Hydrogen and oxygen combine in the ratio 1:8 by mass. Mass of hydrogen is 3 grams. Now 1 gram of hydrogen can react with 8 grams of oxygen. So 3 grams of hydrogen will react with 24 grams of oxygen. It is very simple multiplication, 3 into 8. So mass of oxygen required is equal to 24 grams. So 24 grams of oxygen is required to react completely with 3 grams of hydrogen. So the answer is very clear because mass ratio is a constant one. Which postulate of Dalton's atomic theory is the result of law of conservation of mass? You have to think and answer. Which is that? Answer is this. The postulate of Dr. Dalton's atomic theory that explains the law of conservation of mass is atoms can neither be created nor destroyed in a chemical reaction. They are simply rearranged. That is the postulate which is conservation of mass. Mass is not destroyed. Mass is constant. That is the Dalton's atomic theory that explains the law of conservation of mass. Atoms can neither be created nor destroyed in a chemical reaction. They are simply rearranged. Now the next question. Which postulate of Dalton's atomic theory can explain the law of definite proportions? Law of definite proportions. Which postulate? Think. Answer to the above question is the relative number and kinds of atoms in a given compound are constant. This is the Dalton's postulate. The relative number and kinds of atoms in a given compound are constant. What this means? This means that compound is always made up of the same types of atoms. combined in the same fixed whole number ratio. For example, water, if you take H2O, here two hydrogen atoms are there, one oxygen atoms are there. One oxygen atom and two hydrogen atoms. Because they are same type of atoms are combining and forming atoms. Number two, they are having a fixed ratio, that is 2 is to 1, two hydrogen atom and one oxygen atom. So relative number and relative number what? This 2 is one number related to another one oxygen number, 2 is to 1. And kinds of atom what? Hydrogen and oxygen. No other kind of atom can combine to form water. Water can be obtained from anywhere, no matter from where it is obtained. But the relative number and kinds of atoms in that particular compound are always constant. This is what Dalton's atomic theory says. Atoms, as you know, are very, very small, tiny particles. You should know the size of the atom. Atomic radius is measured in nanometers. That is very, very small. What is a nanometer then? The question may be asked. 1 nanometer is equal to 1 divided by 10 to the power 9 meters. That means 1 nanometer is equal to 10 to the power minus 9 meter, or 1 meter is equal to 10 to the power 9 nanometer. So radius of the atom, for example hydrogen, is equal to 10 to the power minus 10 meter. That means how much small it is. Very, 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 very small. You cannot imagine how small an hydrogen atom is. So this is one aspect you should understand. Next one, there is a abbreviation IUPAC. IUPAC. What is IUPAC? You may be asked. It is an abbreviation for, abbreviation you can say, or abbreviation you can say, International Union of Pure and Applied Chemistry. It is an abbreviation for International I, U for Union, P for Pure, A for Applied, C for Chemistry. This is a scientific organization, international scientific organization. So it approves the names of elements, symbols, and units. So, for example, you say chlorine, they only say Cl. They have approved this symbol. For example, sulfur or silicon. Silicon, they say Si. They say like that. They are putting symbols to various elements and also units. So the first letter of the symbol is always written as a capital letter, as I already told you, uppercase, and the second letter is a small letter, lowercase. For example, if you want to write chlorine, C should be capital, L should be small. Don't forget this. Mass. Each element had a characteristic atomic mass. Carbon 12 is assigned with an atomic mass of 12 AMU, atomic mass unit. This is the reference. Why it is? Because carbon 12 has 6 protons and 6 neutrons, so they assign as 12. Hydrogen, if you take for example, it is containing 1 proton and 0 neutron. So total is 1 only. So atomic mass of carbon is taken as the reference and that of hydrogen is 1 unit. So atomic mass of other elements, the examples are given. Nitrogen is 14, oxygen is 16, sodium is 23, chlorine is 35.5. Like that we can see in the table what is the atomic mass of each element. The atomic mass unit AMU, also called Unified Atomic Mass Unit, hereafter we will only refer U instead of AMU, is a standard unit of mass used to express atomic and molecular masses. Now hereafter we will put atomic mass means we will put the unit U, and molecular masses you also put U. Likewise, we take carbon as the standard, that is carbon 12 is the standard with the 12 atomic mass unit, that is 12 units. So with reference to carbon, all other elements are assigned respective values. So we have to take these values as atomic mass units. One atomic mass unit is equal to 1 by 12th of the mass of one atom of carbon 12. This is a very important thing. 1/12 of the mass of one atom of carbon 12. It is one atomic mass unit. That is the definition. The relative atomic masses of all elements have been found with respect to an atom of carbon 12. Now the question, why is it not possible to see an atom with naked eyes? Already I asked this. To brush up, I am asking again. The human eye can resolve objects only down to about 0.1 millimeters. That is 10 to the power minus 4 meters only it can see. Atoms are about a million times smaller than that limit. Atoms are about million times smaller than our limit. So humans may not be able to see atoms with naked eyes. This is the answer you have to say. What is a molecule? Now we saw the atoms. Now we are going to see what is a molecule. A molecule can be defined as the smallest particle of an element or a compound. It can also be an element or a compound. It is a group of two or more atoms chemically bonded together. The atoms in a molecule can be of the same element or of different elements. They are tightly held together by attractive forces. Molecule of same element, for example, O2. In O2, there are two atoms bonded together. It is a molecule. So same element. Different element, H2O, water. It is a molecule of water. O2 is a molecule of oxygen. O is an atom. O2 is a molecule. Similarly, hydrogen also same. H is hydrogen, one atom. H2 is containing two atoms of hydrogen bonded together. H cannot exist like that. H2 only can exist. That's a molecule. So molecule of water has got different elements. One is oxygen, other one is hydrogen. Here, oxygen molecule is having only one element, but two atoms are bonded together. So you are able to now understand the very definition. A molecule is the smallest particle, smallest part of an element or a compound. Element or a compound. That is very important. To now know what is atomicity. Spelling ATOMICITY. You have to understand the spelling properly. Atomicity. Molecules of many elements such as argon, AR, A capital or small letter, symbol. Helium, HE, H capital, E small letter, etc. are made up of only one atom of that element. So they are called monoatomic. They are called monoatomic. But This is not the case with most of the non-metals. For example, a molecule of oxygen consists of two atoms of oxygen, and hence it is known as a diatomic molecule. It can exist only as O2. That means it is containing two atoms of oxygen. So diatomic molecule is oxygen. Similarly, if three atoms of oxygen unite in a molecule, instead of the usual two atoms, we get ozone, O3. Ozone is oxygen 3, that is three atoms of oxygen combined together to form ozone. This is triatomic. So the number of atoms constituting a molecule is known as atomicity. So what is atomicity? The number of atoms constituting a molecule is known as atomicity. So you should not forget this. We'll see now compound combining ratio. The combining ratio of a compound is a fixed ratio in which different elements are chemically combined either by mass or by atoms to form that compound. Combining ratio by mass, for example, water, if you take H2O is the water molecule, then atom ratio is there are two hydrogen atoms, one oxygen atom. So atom ratio is 2:1. But what is the mass ratio? There are two hydrogen atoms. Mass of hydrogen is 1, that is AMU is 1. Mass of oxygen is 16, that is given when compared to the carbon atom which already we studied, that is 12 as the basis. So oxygen is 16. So 2:16 is the mass ratio, that is equal to 1:8. This is as per the law of definite proportions. So oxygen will combine only in the ratio of 1:8. One hydrogen atom will combine with 8 grams of oxygen atom. 1 gram of hydrogen atom will combine with 8 grams of oxygen atom. This is the ratio. Oxygen mass is 16. You should refer the table. Hydrogen mass is 1. So we have to have two hydrogen atoms. 2:16, that is 1:8. This is as per the law of definite proportions. Combining ratio by number of atoms. The combining ratio by number of atoms simply tells us how many atoms of each element are present in a molecule of a compound. This is directly obtained from the chemical formula. For example, if you take water, H2O, there are two hydrogen atoms, one oxygen atom. The combining ratio is 2:1. The combining ratio by number of atoms is expressed in the law of definite proportions that you may see. The atomic number of an element is the number of protons present. What is atomic number? It is the number of protons present. It is denoted by Z. Mass number. The mass number of an atom is the total number of protons and neutrons present in the nucleus. That is, total number of protons and neutrons is the mass number. It is denoted by A. For example, if you take hydrogen atom, it contains one proton and one electron. Atomic number of hydrogen is 1 because there is only one proton. What about the mass number? Mass number of hydrogen is also 1 because it does not contain any neutron. So mass number of hydrogen is 1 because there is no neutron. Proton plus neutron is also equal to 1. You understand it very clearly now. See hydrogen atom. In hydrogen atom, there is a nucleus here. In this nucleus, there is only one proton and there is no neutron. And electrons are orbiting around. Only one electron is there. So atomic number is equal to 1. Mass number is equal to 1. You see the oxygen atom. In oxygen atom, there are 8 protons and 8 neutrons. Atomic number of oxygen is 8. There are only 8 protons. So atomic number is 8. What about the mass number? Mass number is 8 proton plus 8 neutron, that is 16. So protons plus neutron is the mass number. You are now very clearly understanding what is a mass number and what is a atomic number. Atomic number is only about protons. Mass number is protons plus neutron. We will see what is an ion. An ion is an atom or a group of atoms that carries an electric charge because it has lost or gained one electron or two electrons. Some electrons it has lost. If an atom loses electron, it becomes positively charged. If it loses electrons means it is positively charged and is called cation. If an atom gains electron, it becomes negatively charged. It is called anion. Hydrogen atom loses one electron and it becomes positively charged and is a cation. In the case of oxygen, there are 6 electrons in the outermost shell, but in order to have 8 electrons for stability, it attracts 2 more electrons, so it becomes negatively charged and is an anion. Oxygen atom is an anion. So you understand what is an ion. Ion means it is a charged one. It is either negatively charged or positively charged, depending upon whether it loses the electron or gains the electron. We will see what is valency. Valency, there is a spelling mistake. V-A-L-E-N-C-Y. Valency. The combining power or the capacity for combining of an element is known as its valency. Suppose oxygen is wanting to combine with hydrogen. What is the power of combination? That is denoted by its valency. You may say the valency of an element is the number of electrons an atom loses or number of electrons it gains or it shares to achieve stable electronic configuration. For example, if you take oxygen, for example, we have the atomic number as 8. Then configuration of the oxygen is, in the first orbit is 2 electrons are orbiting. In the second orbit, it is 6 electrons are orbiting. But in order to have stability, it wants to gain two more electrons. That means it requires 8 electrons in the second orbit. So the valency is 2 because it gains 2 electrons. Similarly, hydrogen, it may share 1 electron outside or acquire 1 more electron here. That means hydrogen's valency is 1 to have a complete shell formation. So valency is the one which is defined as the number of electrons it loses or number of electrons it gains or number of electrons it is sharing. That is called valency. What is meant by the term chemical formula? A chemical formula is a symbolic representation of a compound that shows this is the symbolic representation. 2H2 plus O2 is equal to 2H2O. What it shows? The elements present. Hydrogen is present, oxygen is present. Two elements. The ratio of atoms of each element. What is the number of elements here? 2H2, O2, 2 oxygen. So 4 hydrogen and 1 oxygen. 2 oxygen are present in the product. So it shows the equation, reactants and the product. So this is a symbolic representation of the compound. So that is the equation, chemical formula. I finished my lecture here on atoms and molecules. And you have to do a lot of work. You students have to do a lot of work. And if you make efforts, I believe that your efforts will never fail. Wish you success in your endeavors.